All right, so here we're back. Got the audio working, it looks like. So we're feeling really good about that. And again, we'll just do a little recap here. So I am Dr. Dejana, and I'm here with Rainbow Seal Girl and
Cold Ramen.
And we're going to do the states of matter. So if you're joining us again, thank you. We had to help work out those technical difficulties. Those totally happen. But we're here with the 2-Bit Circus Foundation, sponsored by Vans, and we're presenting an hour of playful learning. I'm here again with Rainbow Seal Girl and Cold Ramen. And now, here with our audio. Yes, they can hear us now. We are good to go. So what we're working on right now is we're going to try and to describe what happens to matter when we change it. So there's two things that are happening right now. We've got Cold Ramen over there. She's going to be using bricks. Now, each brick models a molecule. All material, all matter is made up of atoms, and atoms, when combined together, make molecules. So we are going to model the molecules using bricks. And in Minecraft, we're also going to model molecules using bricks. So, Rainbow Sugar, are you ready to open and enable your Minecraft?
Sure.
All right. I'm going to check on our chat and see if our audio is working, okay? While you guys kind of build. Now, what they didn't hear was us discussing about the water cycle. So while you're building, can you share a little bit about how the water cycle describes the different states of matter for water?
How water never really goes away. It just gets transformed. If you start off as a solid, as ice, eventually it'll melt, and when it melts, it turns into liquid. And then if you keep on letting that melt, I guess, it turns into gas.
kind of.
Right?
Yeah, Rainbow Seal Girl,
It evaporates.
Can you tell me a little bit about the water cycle too? You have it on dot. So you have ice. You start off with ice, and then you put your ice out on a sunny day, a big old block of ice, and you put it out on your patio on a sunny day. What happens to that ice?
Well, it's most likely going to turn into water.
It's going to turn into water. And what state of matter is water?
Water is a liquid.
All right, so we've got water as a liquid, and then when it was ice, what state of matter was the ice?
Solid.
All right, so we go from solid to liquid. Again, it was a really hot day. We got this big ice cube. We put it outside. It started to melt. It turned into liquid water. What happens if we leave that water out there in the sun?
Evaporation.
Was that a song? A little evaporation.
Yeah.
We might get us started with this entire evaporation song. We do have a song we totally do have a song for the water cycle. But yeah, it will evaporate and turn into what type of water? What state of matter is it if it's evaporated?
A gas.
It's a gas. It's a gas. But is it still water though? Like, are the water molecules still there, or do they disappear?
They're still there.
How do you know? How do you know?
Well, how would we have rain without evaporation?
Oh, so are you telling me that the water that evaporated and went up into the atmosphere as gas can also come back down as liquid water again.
Yep.
That's pretty cool. That's pretty cool. So really, matter is cool. It's anything that we see around us, anything that has mass and takes up space. And it exists in 4 fundamental states. We've got solid, which we used ice as our example. We've got liquid, which we used liquid water, like drinking water as our example. And then we have gas, and we used water vapor as our example. But there's a 4th fundamental state of matter that we didn't really talk about, and that is plasma. Have you guys ever heard of plasma before?
Yep.
No.
When I studied the blood, but that's a different plasma.
Oh, yeah, that's right. The blood plasma is a different type of plasma that we're talking about right here. It's completely different. Plasma, phasma. It's a little different than what we're talking about right here. We are talking about a state of matter called plasma. So the girls haven't heard about plasma before, but let me tell you, it's actually really, really cool. Plasma is actually gas. No joke. It's gas. Like, it's the gas state. But the gas is what we call ionized.
Oh.
Fancy word.
Right? Don't you love it? We could just drop some fancy word vocabulary here. Ionized gas is what we call plasma. It's kind of cool. Now, you need to know a little bit of chemistry to really understand what we mean by ionized gas. But it turns out that, let's do a quick little deep dive into chemistry really quickly. I'm sorry. I apologize in advance for all of the fancy words I might be using. Okay?
Okay.
So, matter is anything that has mass and takes up space. We are all made out of matter, but if you zoomed into matter, you would find that matter is made out of atoms. That's right, atoms, the building blocks of matter. And then if you zoomed into the atom, you would see that there's subatomic particles that have special properties inside of the atom that are called protons, neutrons, and
electrons.
oh yeah, we really should make a song about this because all of those words end with tron, and I'm just thinking that would be a really cool, we could do a deep dive. So we've got our matter. Matter is made up of atoms, and if we zoomed into the atoms, we would see that there are subatomic particles, protons, neutrons, and
Electrons.
And it turns out that your gas that's made out of matter, something's going on with its electrons if it's plasma, okay? And that ionizes the material if they have just a little bit less or fewer electrons than they would normally have. We'll do a deep dive on that when we do a chemistry lesson. But just for now, know that there's 4 fundamental states of matter. We've got solid, liquid, gas, and plasma. Plasma's just gas. It's ionized. All right.
Okay, this is not looking like a sheep right now.
All right, what are you making over
Can I
here?
help you?
Let's see here. Rainbow Silk Girl, what are you working on?
I'm trying to make a 3D sheep.
All right, so I gave them instructions to just build something. They can just build something. But I told them that each brick is representing a molecule. So right now, we're just basically building things either in Minecraft or with Legos, and keeping in mind that each brick that we use represents a molecule. It's kind of cool. All right. So I'm going to go over here to the Lego side.
Oh my god.
Yep.
While you continue to build over there, Rainbow Silk. Cold ramen.
Yeah.
All right. So I'm here. Let's turn that camera a little bit so they can see us just a little bit, Rainbow Silk Girl. Maybe a little bit. All right. So Cold Ramen has built a really cool structure here.
It's supposed to be a sunflower?
Oh, all right. So she's built a sunflower. It looks like you used green and yellow. It's actually really pretty. So if each one of these molecules, the bricks, represent a molecule, let's weigh it and see how much this weighs. Yeah?
Okay.
So we've got our scale. We're going to turn the scale on. Currently, depending on if you have a scale at home, I borrowed this scale from the kitchen. And so this is our kitchen scale that we use for cooking, but I borrowed it today so that we can measure how much these molecules, remember the bricks represent molecules, weigh. So let's write down that your sunflower weighs 133 grams.
So
Sunflower, 133 grams. So we'll remember.
This is an interesting looking sheep.
Awesome. Got it. So now, check this out. This is our, remember, every brick represents our molecule. So now, I want you to, take that guy apart. Take him completely apart, and I want you to make something completely new. Completely new over there.
Okay.
All right, let's check out what's going on over here.
The eyes are too low.
Okay, what are you making over here?
I'm trying to make a sheep.
Okay, that's cool, because I gave you instructions. Just build something, and every single brick represents a molecule.
Yeah, this might be the really big sheep.
Well, let's stop right there. Let me take a look at it before you do any changes. Are those the eyes right there?
Yeah, I'm gonna make.
Okay, and why don't you fly around them for me so I can just kind of see what's going on here?
Well, right now I'm working on the head, but that's it.
Okay, cool. So
Yeah.
let's pause right here. This is going to be difficult. We're going to need to count these bricks because I can't actually go into Minecraft, take your model out of Minecraft, and put it on the scale and weigh it. So can you count each one of those bricks that you used for this?
But I'm not done yet.
Well, I want you to, we're going to make something else. You want to spend a little bit more time on this guy?
Yeah.
All right, she wants to spend a little bit more time on it now. Let's take a look at what we have going on. Oh, there's people are so funny. Some of the things that we say remind them of other things in the world, and it's kind of cool.
Like what?
Well, we've got some comments that says, oh, I shared that we took that scale from the kitchen, and we have starts on it replies, cooking involves change in states of matter.
Actually, I think I'm gonna make this a lion.
IQ.
That looks more like a lion.
Okay.
Wait, you guys, if cooking involves changes, can anybody give me an example of something that we've cooked where we've physically observed a change in the state of matter? Think about it.
Pancake.
A pancake.
Yep.
Okay, so what is the first state for pancakes? Like
Just
what
the
are you?
ingredients separated?
Okay, so you've got solid. Wait, is it solid, liquid, or do you put those things together and make a liquid?
You put them together and they make a liquid.
So your pancake batter, is that solid, liquid, gas, or plasma?
Liquid.
Wait, wouldn't that be awesome if you could have a plasmic pancake? But anyhow, that's for another day. Plasmic pancake. That just sounds
delicious.
Awesome. And we need to figure out how to make one of those. All right, so you're starting off with your liquid batter, and then you pour your batter onto the griddle and cook it, and then do you end up with a liquid pancake?
Nope.
You end up with what type of pancake?
A solid pancake.
A solid pancake. That's right. Oh, somebody else is thinking about plasma cakes right now. Yummy, yummy, yummy. I can't wait. Plasma cakes. Yeah, that's right. So, yeah, that's a cool one in cooking. And then even when you bake a cake, you know, like when we bake the cake and we put the batter in there, you can see a change in the state of matter, which is that's kind of cool. When I boil water, has anybody, or am I the only one that sometimes boils eggs and then forgets that they're boiling, and then I come back and there's only eggs in there and no water?
What?
Yes, because the water has completely evaporated, which is kind of cool. Now, when we're talking about states of matter, you guys, it's kind of cool to think about all the matter that you see around you. I'm not even kidding. Let me get one of these bricks and put it in frame right now. The matter, this brick is made out of matter. The matter that you see around you, it can actually exist in different states. So for example, if we took this Lego brick and put it in a smelter.
Oh my gosh. A smelter.
We could probably raise the temperature high enough so that it would melt
But that's
and
bad
turn into a liquid.
for the environment.
That might be bad for the environment, and we don't actually have a device that would heat this thing up enough to melt it, but it's possible. And then if we continue to add energy or heat, we could even maybe turn it into Lego vapor, like gas.
Wait,
Like
what?
a vapor.
I'm not kidding. I am not kidding, because matter, no matter what type of matter it
Wait,
is,
no,
be
matter.
different.
So much matters.
Got it. Matter, no matter matter. Yep. Matter, no matter what type it is, it can be in the different states.
Like United States.
No, the states of matter. Oh my goodness. No, we're not talking about the United States. the United States. We're talking about the states of matter. Oh my gosh.
The sheep is almost done.
Oh my
I
gosh.
don't even know what I'm
So
making.
wait, you did not add any more bricks, right? It's the same amount
Same
that
bricks.
you've used already. Okay.
Same bricks.
That's kind of important. Did we make we did make a prediction that what happens when water turns into gas is it disappears, right? Is that what our prediction was?
No.
What do you mean disappears?
Like it just goes into the...
Like it's out of sight? Or...
No, it's like gone. It disappears from existence.
Mm-mm.
You do not agree with me.
No. Hey, I might finish my sheep.
Wait, so if I were to
Oh.
vaporize
Why do
these
you think we have
Legos...
climate change?